Hello everyone, welcome to Infinite Loop and another session on data structures and algorithms. So it's very good to meet you all because this is another new session and the new topic that we are going to start as part of DSA, right? So far we have came a long way, right? Like we have discussed complete basics related to data structures and algorithms. Like we have seen what are the data types, and we have came through operators as well, right? What is the need of operators while solving the problems, and we have also stretched more on bitwise operators. We have made a separate video on this bitwise operators, guys. If you are interested, you can watch that video as well. And we have seen that why we need to optimize our code, and how we can handle these long numbers using integer and long, right? Long. Along with that, we have also seen like time complexity, right? How time complexity will play a crucial role, while solving the problem. Of course, it will not help anything making you to optimize the problem, but this time complexity will make sure that you go through a proper solution, an efficient solution. And along with that, we have solved, some examples, and we have found out time complexities for these examples, right? You can watch those videos as well if you are interested. And along with that, we have seen the space complexity, right? So in this video, right, in this video we will try to discuss everything related to bit manipulation. Okay, if you want to learn about bit manipulation or bitwise operators, everything, like each and every concept that is included for solving any problem. Okay, if you want to solve any problem, like I'm mentioning specifically for any coding problem. Okay, if you want to solve any coding problem, and if there is a approach that you can use bit manipulation, that means you can use a bit manipulation method so that you can get a proper solution for the problem, then definitely this video will be useful for you guys. Okay, so in this session we will completely discuss each and every concept that we have in bit manipulation. Okay, we will see each and every bit algorithm, and we will see whatever the things that are required so that we can solve any problem, any given problem, using this bit manipulation. Okay, so before going into the session, let me try to revise the basics that we have seen in our earlier bitwise operators video, right? Like we have seen complete basics about bitwise operators, right? If you are interested, you can watch that video, guys. But in this video I would like to give a quick revision or quick recap related to this bitwise operators. Okay, so we know that basically there are how many operators you have: bitwise and, you have bitwise or, and you have bitwise XOR operator, and you have negation, and you can you have left shift, you have right shift, I mean sorry, you have left right shift, and you have left shift. So we basically have these bitwise operators, and we know that these operators are intended to use only for bitwise representation of numbers. Of course, each number is a bit. Each number in any computer will be stored in terms of bits, right? So if you want to play with that bits, or if you want to perform any operations with respect to those bits present in this number, then you can use this operators, right? We know that AND operator is as simple as that. If both are 1, then it will become 1. Otherwise, in the remaining cases, it will be 0. And we also know bitwise OR operator. If any one of them is 1, then definitely the output will be 1. Here you can see 1, here you can see 1, and here you can see both as 1. But here it is 0. Why? Because both the numbers are zeros. And we know XOR operator. Guys, this XOR operator will play a crucial role in many of your technical interviews as well. Okay, if an interviewer asks you a question related to bit manipulation, or if he gives any problem, then there is definitely a way that you can think of an XOR solution for that problem. Okay, so this XOR will play a crucial role, and we know that XOR will operate, it is as simple as that. Like if both the numbers are same, you can see both the numbers are same, then it will become 0. And here also you can see both the numbers are same. Otherwise what happens? Otherwise it will become 1. This is a basic thing that we know related to XOR operation, right? And negation is nothing but you are just flipping the number. Like if it is 0, then you are flipping to 1, and if it is 0, you are flipping it to 1 again. Here it's 1, you are flipped to 0 again, flip to 0. So these operators are very simple, guys. I think most of the people know details about these operators, and if you don't know anything related to these operators, it's okay. You can watch my tutorial. You can visit my channel and you can watch the Bitwise operators tutorial. Okay, so it is as simple as that. Coming to these cheat operators, guys, we have also seen that how these cheat operators will be useful while solving any problems related to bitwise operators, right? Like we have seen, if both the numbers are same and if we apply an AND operation, it will be the same number. And you can see what happens if both numbers are same and you apply an OR operation, then it will again be a same number. And we have also seen XOR operation between two numbers. This is one of the most important thing, right? If you apply XOR between two same numbers, then it will definitely become zero. So in the same way you can use these things also. Okay, right? We have seen everything related to these details in the video, right? Bitwise operators. And if you have any doubts, you can practically take any example, like you can take any value of a and you can check how it is becoming equal to these things. Okay, of course you don't need to remember each and everything, right? Okay, I'm just giving you so that it happens to be like this. Okay, no need to remember everything. You can do manually while solving the problems as well. Okay, so just you go through these things, and this is the most important thing you need to go through. Okay, you will be getting zero, right? And along with that, this is also most important thing. If you apply if you take any number and if you apply and with one, then if you take the same number and if you apply an modulo with two, then both the results will be same. Okay, so these two properties will play a crucial role, guys. I have seen in most of the problems these two things will play a crucial role. Okay, so these are the cheat operators, guys. You just go through them. Okay, it's not necessary to learn each and every one of them. And along with that, coming to the next thing, what is the next thing? Simple thing, left shift, right? Left shift, right shift are also very crucial thing while solving problems related to bit manipulation. We know what is left shift, right? We simply shift all numbers to the left side. Okay, you can clearly see we have shift each and every number to the left side, and we have inserted 0 at the end. That's it. This is a new bitwise representation of your new number. And similarly, what will be for right shift? You will right shift each and every number and you will insert 0 at the starting position. So both are similar, but you can clearly see 0 is been inserted at the ending position and here 0 is inserted at the starting position, right? And also one of the most important thing is you are removing the starting number. That means if you have any bitwise representation of something like this, you will remove the first number and you will insert 0 at the last. You can clearly see this is our representation. Okay, we have removed this one. For what? For left shift operator. And similarly for right shift operator, we'll do again the same thing but in a reverse manner. Like we will right shift everything, we will remove the last one and we will add 0 at the starting position. Now this will be our new representation, right? Okay, now you might be getting confused. Oh, arey yaar, what's this? What are these things? Like it's very difficult to do for each and every number. Is it really required for to learn this left shift, right shift? I'll tell you one easy funda, guys. If you have some number like this, like I'm writing it in a bitwise representation, if you are set to right shift by one, the simple thing that you can do is you just right shift it by one. That means if you have number like this, right? I'm telling right shift by one. That means you right shift this by one so that it will go off. Now this will be your new number. Okay. Similarly, if I tell the same new number to right shift by one, again what you will do, you will remove this zero and you will write the new number. Similarly, it goes on, guys. Okay, there is nothing difficult in doing this left shift and right shift. Okay. Similarly, for left shift, what you will do? If I do the same thing for left shift, like 0 1 0 1 0, left shift by 1, then what you will do? Simple. You will, left shift it by 1 and you will write the remaining result. Okay. So it is as simple as that, guys. Okay. Don't get confused with this left shift, right shift. And if you're still getting confused, then I will tell you one of the easiest method. Okay. This is one of the, easiest funda that you can, do while doing left shift or right shift. Okay. Suppose if you are given with a number 2 and you are set to left shift by 1. Simple thing, guys, what you do is you take this number and you multiply this number with 2 power 1. Okay, 2 power 1 in the sense whatever number that means how many times it is set to left shift, right? And those many times you do 2 power. Okay, let's say if given 2 left shift 2 times, then you do something like 2 into 2 power 2. What I'm doing? I'm doing the same thing, multiplying 2 with, but I'm keeping here power 2. Okay, so only the power is changing. The simple thing that you're doing is you're multiplying your number, whatever number you are told to left shift, right? You're multiplying that number with powers of 2. And how many powers of 2 you are multiplying? Based on the number of times it is told. Like if it is told for one time, you're left shifting it for, multiplying it for 2 power 1 time. And if you're told with 2 times, then you're doing with 2 power 2 times. This is left shift. That's it. You got everything related to left shift, right? With this simple formula. Simple. If you have any a left shift I times, then you will multiply that a with 2 power I times. Similarly, for right shift also there is one formula. Instead of multiplication, you replace it with division. That's it. It's as simple as that. Okay. So I have told you 3 methods, guys. You can see this is one of the method. Like you will, if you are given to left shift, then you will shift all the numbers and you will insert 0 at the end, and you will remove the first number. And for right shift, you will do all numbers right shift, and you will discard the last number and you will add 0 at the end. Okay. And if you are confused with this method, then you can use this method, right? I've told how you can remove this, last number and first number for left shift and right shift. And if you're confused with this method as well, then you can simply blindly go with this formula. Okay, of course, you might be getting like where we can use this left shift right shift. If we try to see examples, then you will definitely get some complete clarity related to this left shift and right shift. Okay, so far these are the things that we have discussed, guys. Okay, so we have seen many things, right? Like we have seen the operators and we have seen some cheat operators, right? Now we will talk the actual concepts that are related to bit manipulation. Okay, related to what? Bit manipulation. Now, before telling the concepts, I want to tell you some facts. Okay, simple facts based on the previous discussion, right? You have left shift and right shift, right? Remember one thing, you cannot do left shift and right shift with negative numbers. Okay, this is one of the most important thing that you need to remember. Okay, because it is, it's not a good thing, or if it's completely logicless, right? Because you are doing left shift and right shift with of course you can apply operations with negative numbers. Like you can apply the bitwise operations with these negative numbers, but left shift right shift will be confusing if there are negative numbers, because you'll be getting confused where to place that negative sign, and it's completely a illogical thing, right? So that's why the rule number one is don't apply for negative numbers. Okay, and the second thing is XOR operator. As I told, this operator will be very very useful, guys. Okay, make sure that this is an important operator. May use this operator for any problems if you are finding any difficulty. Okay, and the third thing is, know the difference between logical operators and bitwise operators. Okay, you know where to apply logical operators and you know where to apply bitwise operators, right? Bitwise operators you can apply between numbers, right? You can apply between any 2 3 or any number of numbers. But logical operator is what? It is to check the condition. It is used for what? Check the condition. That means if both the statements are logically true or false, you can check it using logical operators. Okay, and don't get confused, like two double and is different and this one single and is different. Hope you know this, right? So this is basically, while discussing anything about bit manipulation, we use this thing, right? Single and single or, and single XOR, like this. Okay, so know the difference between these both. And of course, the one more most important thing is left shift operator and right shift operator. You know that this is applied for what? You can simply multiply the number with 2. Okay, here you can divide the number with 2. But one thing is important, don't just multiply it with 2, but know the power. Okay, know the power. I'm writing here, know the power. Now you might be getting doubt, what is the power? Simple, the power is how many times you are left shifting or right shifting. If I told left shift number 1 with 3 times, then here you are clearly seeing that you need to multiply this number with 2 power 3. And if you are told with left shift 4 times, you can clearly see you need to multiply it with 2 power 4. Similarly, it applies for division as well. Okay, divide by 2 power something. Okay, so know the power and you apply this, left shift and right shift operations. Okay, and finally remember one thing: if you are using any bitwise operations in your coding problem, okay, if you are trying to use any bitwise operations, remember that it will take constant time, constant time, and of course space as well. Okay, so remember this, this is an important thing. Okay, that's why most of the problems we will try to look at into bitwise operators. If big O of n solution is also not working for some problems, then definitely there might be a case that you can apply it using, there is definitely that you can apply it using big O of 1, and if it is big O of 1, then simply you can use what, bitwise operations or bit manipulation concepts. Okay guys, we have seen many things, right? Some important facts we have seen, right? Like we should not handle with negative numbers and XOR is important, and know the difference between logical bitwise operators, and we have seen how left shift right shift will multiplication and division things, and we have seen that big of one constant time, these operations will take constant time. Okay, now we will discuss about the last topic in this session, guys. I want to tell you about bitwise algorithms. Remember guys, this is the most important part of discussion or important part of this video. Okay, if you get to know about these algorithms, you can solve any problem using bitwise operators. Okay, any problem, whatever problem, if that problem requires to be given a solution using bit manipulation, then definitely you can use these concepts. Okay, the first concept is, set bit. Let's say you are given with a number 5. Okay, can you tell me how we can represent it using bitwise operators? 4 plus 1 is 5, right? So we can write something like this. It is 2 power 2, 4, it is 1. 4 plus 1, 5. Let's say set bit is nothing but, remember set bit is nothing but, these 1 is called as set bit. Okay, 1 is nothing but set, 0 is nothing but unset. This is a language that we will speak in this bit manipulation. Okay, set is nothing but 1, unset is nothing but 0. It's just like if you have a bulb, turning on the bulb means set, turning off the bulb means unset. Similar to this, set is nothing but 1 and unset is nothing but 0. Okay, hope you got about whatever discussion about set bit, right? And the second thing is unset bit. You might be getting to know, right? Unset bit is nothing but 0. Okay, set is nothing but 1, unset bit is nothing but 0. Now we will try to know some discussions about this set bit and unset bit. Let's say I have given with the same number 0101, like I'm writing it in bitwise operators. Okay, uh, you know how many set bits are there in this number? There are 2 set bits. And how many unset bits are there? There are 2 unset bits. So it is as simple as that. Let's say you are given to find out whether that bit at particular location is set or unset, right? Then what operations can you do? Can you find the solution for it? Like I've given you 0101, I want to know this bit is set or not. I mean, if I count from this position 1 2 3, I want to know third bit is set or not. Can you tell me how we can do? We have seen this, right? In our bitwise operators, we have seen 5 major examples of bitwise operators, how we can solve this, right? It is as simple as that, right? If then any number is given, the idea is what, you need to bring this number to this last position. Okay, you need to bring whatever number that whatever the position that is required to check, right? Here the question is check the position. Okay, position is given as 3, and if you want to check if that position 3 is set or not, then what you can do, you just can't directly check, right? You just can't traverse or do something. We'll try to bring this to this 0th position. If we try to bring it to the 0th position, we know that, let's say I have brought that to something like this. Okay, let's say I've brought this one to this position. Okay, by right shifting, you know that if I right shift this by one time, it becomes 0 1 0. Again, if I right shift, it becomes 0 1, right? I'm writing this thing only here. Okay, like I've kept these zeros. Okay, so what, this is the final number. Now you know how to check this bit as set or not, like, right? You just simply apply an AND operator with 1. This is nothing but 1, right? So you simply apply and if you are getting 1, then you can say that this position, this third position is set. Okay, and if you don't get it as 1, I mean if you get it as 0, then you can say it as unset. So it is as simple as that, guys. We know these things, right? Of course, if you are facing any difficulties, we'll try to discuss, some detailed examples as well. We'll try to review the previous video. Okay, we'll try to review that video and we'll see. But as a part of this, algorithms or something related to the bitwise operators, remember that set bit is nothing but 1 and unset bit is nothing but 0. And talking about next thing, you will be telling something like toggle the bits. Remember, toggle is nothing but if there is 1, make it 0. If it is 0, make it 1. It is as simple as that, right? Let's say you have some number like this, and if we and the question is toggle the second bit. Then what you will do? You will write something like this. What we have done? We have toggled this second bit. That's it. Initially it was 1. We have made as 0. Let's say this is our new number now. This is our new number, and the question is toggle the third bit. Then what you will do? You will try to write something like 0 1 0 1 0 1. What we have done? This is the third bit, right? Now we have toggled the third bit. That means 0 has become now 1. Okay, so this is the concept of toggle. Okay, we will try to find out how we can toggle, guys. Okay, I'm just explaining the concepts here. Okay, in this session we will try to discuss only the concepts. In the next session we'll try to see how basically we can solve it using bitwise operators. Okay, like if you want to check a bit as set or not, we have seen right here, like we have right shifted it for position, how many position it's given, how those many times we have right shifted, and we have applied an and with 1, right, to check set or unset. We'll try to see this in the next video. Okay, but as far as this discussion is concerned, try to know what is set bit, you try to know what is unset bit, okay, and what is toggle bit. Okay, and and one more thing is, uh, left shift, right? I have told you left shift and right shift, like multiply by 2, divided by 2 based on the powers, I mean based on the number of times you try to multiply and divide it, right? So we will try to see the examples as well related to this. And of course, you will be given with some different problems, like you will be given with flip all the bits. Flip all the bits. What does this mean? You are given with some number. Let's say this is the number, and the question is flip all the bits. Then what you will do? You will write something like 1010. That means we have flipped each and every bit. Flip is nothing but just you apply negation. That means if it is 0, then make it 1. Something like that, right? Just like toggle. Toggle I have set for individual bits, right? Flipping the bits is nothing but I'm flipping each and every bit. Okay, flip and toggle are something similar to the similar things. Okay, so this was about flipping the bits, guys. Okay, so these are some of the basic concepts. Okay, that you can see in bitwise algorithms. It's very simple. Okay, in the next session, we will discuss basic problems. Okay, simple problems, like if any number is given, you want to check whether that number at some particular position is set or not, how we can do, and whether that particular location or position is unset or not, how we can do, and whether that particular position it's set that to toggle that particular position, then we will see how we can do that. And let's say how these while setting or unsetting, while checking those things, how these left shift and right shift operators will play a crucial role. And we'll try to see how we can flip all the bits. And one of the interesting thing, guys, swap the numbers, right? This problem, I think most of them know this problem, right? If like a is given 1, b is given 2, if I do swap, what happens? A becomes 2, b becomes 1, right? After swap, right? We generally try to do some basic things like a equal to a minus b or something. We will do something like this and we'll try to bring swap, right? That we can apply XOR operator, and also we can swap the numbers. I'll tell you in the next video. Okay, so we can do many things using these bitwise operators. Okay, so just know these things. Okay, what is flip, what is toggle, what is set unset, and of course you need to know what is left shift, right shift, how we can apply them. And XOR will play a crucial role, and of course logical and bitwise operators, don't get confused. And of course these are the basics, you need to know these things, right? And if you are getting any confusion, okay, please have a watch on my using bitwise operators video. Okay, in that video I have explained in detail about these operators, how these operators will work internally. Okay, so these are some of the concepts, guys. Okay, facts and some concepts related to some algorithm concepts, okay, related to bitwise operators. Okay, that is about this session, guys. Thank you for watching, and please try to like, share, and of course don't forget to subscribe to my channel. Okay, and hold that bell icon as well, so that it will recommend you my videos, because we are discussing about the most important concept, bit manipulation. Okay, this is the basic thing that we will discuss while solving any problems or while doing DSA, right? So that's why this series is going to be very interesting. Okay, bit manipulation series, of course it's a part of DSA, but we will try to make it interesting by solving many problems. Okay, thank you, guys.